This is our first video for Chapter 4, Section 7, and it's going to be very much just an introduction. The topic is inverse trig functions, and to get going, I'm just going to talk about inverse functions in general. Hopefully this will be kind of short, just a very quick review. I want you to think about the equation y equals x squared. We're going to talk about it graphically in a little bit, but right now just thinking about it algebraically. What does it mean to find the inverse of this function? And at some point, I'm assuming that you learned one way to do that is to take the equation and flip the x's and y's around, and then take this new equation and solve for y. So, in this idea that I just wrote down in red, after we switch the x's and y's around, how do I do that? I would have to, if I want to solve for y, I need to get rid of the squared sign. So I'm going to take the square root of both ideas. Okay, so I get the square root of x equals y. And there are certainly times where we would think about when we take a square root, we put plus or minus. And I think there are good arguments for and against it in this case. It depends on the context of what you're working in. Right now I'm just going to leave it as is. And generally all I want you to know is that the inverse of y equals x squared is y equals the square root of x. Erase that a second. Okay, let's talk about that graphically for a second. Okay, think about it graphically. If I make that is not a good straight line there. Let's do undo. There we go. If I make a coordinate plane, and I want to think about graphing y equals x squared, okay, we'd have something like that. And so we could start labeling some points here if we wanted to. For example, if I went and so my axes here are going to be, they're not going to be perfectly exact, I suppose. But if I just picked a point right here, if this was y equals x squared, this could be a point 2, 4. When I plug a 2 in, a 4 is going to pop out. And over on this side, if I were to plug in a negative 2, I would also end up with a 4. So what I want you to do is think about what's the inverse of this going to look like. And so another thing that you might have talked about as you studied inverse functions is the fact that graphically, either it reflects across the line y equals x, so across the diagonal like this, or the fact that all the x and y values just switch. So either way, you would end up with a graph kind of like this. And again, my picture is not to scale at all, but I would have the coordinates of 4, 2. Let's see, 4, 2. So yeah, this is just not to scale at all, but I have 4, 2 on there. But I would also have, if I reverse these xy coordinates, I would have 4, -2. If my picture's a little confusing, ask a question in class and I'll show a better picture of this, but that's another way of thinking through this. What I want to point out, though, is that when I look at the blue equation or the blue graph, that is a function. It passes the vertical line test. But when I look at the red function, it's not a function because it does not pass the vertical line test. Or if I look at the blue one, because the blue one does not pass the horizontal line test, its inverse cannot be a function. So whenever I talk about this in terms of a function, the inverse of y equals x squared, a parabola, in terms of the inverse being a function, I need to limit the part of the graph that I look at. And so it has been agreed that we actually will erase the bottom part of this kind of sideways parabola, and I only look at now what is left in red. And that's where our square root function comes from. So the point I want to make in this very quick, short video is that we've already looked at several examples, really. This just happens to be the most common one, but several examples where we have chosen to erase part of the original reflected graph so that the inverse ends up being a function. And we're going to be doing the same thing in our study of inverse trig functions. So I'm going to stop it right there as an intro, and we'll move on to our next video where we look at inverse sine. but feel free to jot down any questions you might have here.